Hello, and welcome to Concentration Units 1, Molarity Review, Part 1. In this section, we are going to be reviewing some of our topics from earlier. So we'll start with a question. And the question is, which of the following concentration measures will change in value as the temperature of the solution changes? Answer is D, molarity. It's the one that we have been using throughout our semester so far. We may have mentioned a couple of the other ones there, but molarity, because it depends on the volume of the solution, will change. So as temperature changes, the volume of materials, they either expand or contract based on the temperature. So the actual concentration, the molarity, will change as the temperature changes. See how it has liters of solution in the denominator. These other units, so molality, which sounds a lot the same, doesn't involve liters of solution, but kilograms of the solvent. So the mass doesn't change as the temperature changes, and neither do moles. Moles is another unit that is constant with temperature. So of course mole fraction isn't going to change, and then mass percent, involving only mass, also will not change as the temperature changes. So you can imagine that might be a little bit of a problem if we're looking at different kinds of reactions where temperature is sort of more extreme than just sort of roundabout room temperature. So we're going to need these other units to account for some things when temperature changes. So let's remind ourselves of a few other things here. So here are a list, all of a whole bunch of concentration units. So again, molarity is the one at the top. It's the one we're the most familiar with. And then we have a whole host of other conversion factors, really. That's what concentration units are, different conversion factors. Depending on sort of what we're measuring, what kind of the size of the concentration is that we're going to be working with, and what units are convenient for measuring. So we are going to, in this video, review molarity. And then in the next in the series, we will deal with a few of these other ones, as well as how to convert between them. Okay, so before we get started, we need to remind you about some terms that are going to come up again and again here. And one of them is density. It's been coming up off and on throughout our semester here. So here's some reminders about density. Density is not one of our concentration units. It is the mass of an object over the volume of that object. It doesn't involve two different things. It's not referring to a mixture of materials. So we can use a density, we can measure a density for both pure substances and for mixtures, combinations of more than one material. Okay, so we may be using density in some of our conversions throughout this series of videos. Molar mass is another concept from earlier in the semester that we have used throughout the semester. It is also not a concentration unit. Again, it refers to the same material in the numerator and the denominator of our ratio here. It's the mass of our substance divided by the moles of that same substance. And because it relies on moles, it's only applicable for pure substances. So we don't have molar masses for mixtures. So our solutions are not going to have molar masses. We can have molar masses of independently the solute or the solvent, but not for the solution as a whole. All right, so here are the skills that we have worked on and that we will work on in this series of videos. So we should be able to calculate a concentration in, again, whatever units we're asked to find them in, whatever is pertinent for the problem that we have at hand. We should be able to make a solution. So that's sort of the physical acting out of that process. How would we actually go and do that in the lab? We should be able to dilute a solution, so calculations involving that. We definitely should be able to use concentration units as conversion factors. So regardless of whether we have molarity, which is familiar, or one of our new ones, we should be able to use it as a conversion factor. So that is going to involve very carefully keeping track of both the unit and the material that we're referring to. And then the newest skill will be converting between these concentration units so that we can easily relate one kind of measurement to another. All right, so we'll begin again with molarity. So remember, that's our big M as our symbol. And the question is, how many grams of lithium acetate are needed in order to make 250.0 milliliters of a 0.300 molar solution? So throughout this video and the others, please make sure you're pausing the video in order to practice those skills on your own. All right, so first off, what we need to do is we're going to need a formula for that compound. That's going to be our solute. Since we start with grams, we're very likely to need moles dealing with molarity. So we will need a chemical formula. So we do need to remember how to go from the name to the formula of things. So in the little red box is our formula of lithium acetate. And the other thing to remind ourselves of is, again, that molarity, that concentration unit, is a conversion factor. So it's been rewritten so it looks more like a conversion factor. And we're going to use the abbreviation La for lithium acetate, so we don't have to keep writing that formula over and over again. And then we'll use SOLN as our shorthand for the solution. So note that we're keeping track of both the unit and the material. Molarity refers to moles of the solute, in this case the lithium acetate, per 1 liter of the whole solution, that mixture, that combination of solute, lithium acetate, and solvent, water. All right, so we need a plan. We're going to start with our volume of lithium acetate solution that's in front of us, and our goal is to find the grams of lithium acetate that are going to be needed to make that solution. Again, note that you've got two different materials, a solution at the beginning and then just the solute, just the lithium acetate at the end. So somewhere in that conversion from milliliters of lithium acetate solution to grams of just the lithium acetate, we're going to need a conversion factor that relates those two different materials. And that is going to be our concentration unit, our molarity. All right, so our plan is to go from milliliters to liters of our solution, right? And we need to be in liters since molarity involves liters of the solution. And then again, you'll note the red arrow that matches our red box that has the molarity information in it. We'll use that conversion to get to moles of lithium acetate, and then finally to grams of our lithium acetate. So here are all the relationships we're going to need. We're going to need to know our prefixes to get from milliliters to liters of our solution. We're going to need to be able to use our conversion factor or use our molarity as a conversion factor in that red arrow step. And then lastly, we need to find the molar mass of our lithium acetate. So we have to remember how to do that using the information on the periodic table and the chemical formula of lithium acetate. Now we can use our dimensional analysis skills and let the units guide us through solving this problem. So here it is all set up for us. Now it's time to pick up our calculators and be mindful of significant figures still. And we get 4.95 grams of lithium acetate. All right, let's try another problem. And this one involves thinking through the practicality and the actual physical skills and steps that you would walk through. So here's your question. How would you make 250.0 milliliters of a 0.300 molar solution of lithium acetate? Again, this is the solution we just did the calculation for, but the question is wanting you to think about what experimental steps you would take in the lab to actually complete this task. All right. So we would need a particular piece of equipment to make solutions. We use volumetric flasks. So we would go and get a clean and dry 250 milliliter volumetric flask, since that's the volume of solution we want to make. we would weigh out the amount of lithium acetate that we calculated in the previous problem that we need to make a particular concentration of this volume for this solution. So we would go ahead and weigh that out. Okay. Then we would add that solid to the volumetric flask and then add not all of the volume of the water yet, but we would add our solvent, the water, just some volume, about 50 milliliters, maybe a little bit more, until we can get that solid to dissolve. So we would swirl it gently, right? We're not going to shake the container. We're going to swirl it gently because we don't want the water to splash up on the sides, because in order to make sure that we have 250.0 milliliters, we only know the volume on these volumetric flasks when the liquid goes right up to that marking on the narrow neck of the flask, which is shown enlarged over here on our screen. And so we're looking to put that meniscus where the bottom of the meniscus is right on the marking, right? So we don't want water splashed up the sides because then that's some volume that we're not being included in the measurement. And once we've gotten that taken care of, then we can put the stopper on top of our volumetric flask and carefully invert it. So let's turn it upside down to mix. Well, thank you for joining me for Concentration Units 1, Molarity Review Part 1. Hope to see you soon in Part 2. Thank you.